Okay, grade 8, welcome back from Christmas vacation. This is your Eggnog and Gingerbread review. These are the 4 chapters we have studied so far this year on integers, fraction operations, algebra, and our last chapter on linear relations. So the first question says, graphing the table of values will result in a straight line. So without having to actually graph it, if I look here and I see the difference is 3, and the difference is 3, and the difference is 4, and here the difference is 1, 1, and 1, in order for it to be linear, those points, the differences between all of the points in the y column and the differences between the points in the x column must be the same. So because we go 3, 3, and 4, I can say that this is not linear, and I can put false. But if I didn't know, I could simply plot 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and go 0, 1, 2, and 3. So 0 on the x, oh no, I got that backwards, don't I? Hey, I'm so silly. Let me just undo this. Let's try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And 1, 2, 3. So 1 and 7. So 1 and 7 would be 1, 2, 3, 4, 5, 6, 7 right there. 2 and 10 would be there. And 3 and thing would be right there. So we actually have not a straight line. Oh, that didn't work out as well as I wanted it to. Just pretend like that. So it actually did not fit on that line because the third point would not be a part of that linear relation. So there is no equation that would match those. So it's not a linear relation. Question 2 says the product of -7 and 3, which means when I multiply those together, the product is greater than the sum of -7 and 3. Well, the product of -7 and 3 is -21. And the sum of those two is -4. Is -21 greater than -4? No, it's not. -21 is a bigger number, but it's definitely not greater, because when we talk about the magnitude or the size of a negative number, the larger the number is, the less magnitude it has. So a -21 is smaller than a -4. Question 3. 1 1/3 divided by 3 is equal or the same thing as 4/3 times 1/3. So if I actually had this question, what I would first do is I change it to an improper fraction, and then I would think in order to solve a division, I have to change to multiplication and use the reciprocal of 3. Since 3 is really 3 over 1, the reciprocal is 1/3, and therefore they are the same thing, and therefore we can say true. They would both give you the same answer. Question number 4. It says the product of 4 and x minus 2 is the same thing as 4x minus 2. Now remember, the answer for this is false, and here's why. 4 groups of x minus 2. Here's an x, and there's a minus 2. And if I had 4 groups of x minus 2, I'd have 2 groups of it, I'd have 3 groups of it, I'd have 4 groups of it. And when I simplify this, this would be the same thing as 4x's, but my constant is not minus 2 as it is over here. My constant is actually minus 8. And we know that because with distributive property, we would multiply 4 times x to get 4x, and 4 times -2 to get -8. So it would be 4x minus 8, not 4x minus 2. Question 5, 8% of 1.6 can be calculated by multiplying 0.8 by 1.6. The answer for this is false, and here's why. 8% as a fraction is 8/100ths, and 8/100ths as a decimal is 0.08, not this. So if I actually did this part here, that would be calculating 80% of 1.6, and this is actually to get 8% of 1.8% of, remember multiplication is of, that would be what I have to do with a calculator to calculate 8%. Question 6 is a multiplication problem, and the reason why I gave you these particular numbers was because you had to see that you can cross-reduce. Now, if you don't cross-reduce, I'll do that way first. You would multiply the numerators, and you would multiply the denominators, and you end up with numbers that are fairly large and uncomfortable. You get 45 over 165. You then realize that both share a factor of 5. When you would divide the numerator and denominator by 5, to give you 9 over 33. And then you might say that's lowest terms, but then what you forget that 33 has 3 as a factor, and so does 9. So both have 3 common, so you can reduce that down to 3/11, which is your answer. However, if you took that same question and realized that when multiplying fractions, you can cross-reduce, then you could look this way and think of that as being 3 over 33. And you could look this way and think of that as being 15 over 5. And when you multiplied that, you would still end up with 45 over 165. But if you started with these fractions, you would never keep 3 over 30. You keep it 1 over 11. And 15 over 5 would be 3 over 1. So what we're going to do is over here, I'm simply going to, oh, hello, come on now. Come on, Bessie, let's go. Let's go. One time. Oh, that's why. All right, it won't let me. So I'm going to cross-reduce 15 over 5, just like I did right here. And that's going to become 3 over 1. And I'm going to cross-reduce 3 over 33. That's going to be 1 over 11. And when I multiply the new numerators, and I multiply the new denominators, I get 3 over 11, which is my answer that I got both ways. But cross-reduction made it much easier. Question 7 is an integer question. There is multiplication here. So according to BEDMAS, I should do that first. So -3 take away -2 plus the product of 8 and -2 is -16. So my next line will look like that. I now have just subtraction and addition. And when I have subtraction and addition, I just do them in the order they appear from left to right. So I'm going to keep flip change when subtracting. And 3 negatives and 2 positives make 1 negative plus -16. The answer is -17. Question 8 is algebra. I have a two-step algebraic equation. I have a constant and I have a coefficient. Don't forget the coefficient in this equation is -2 and not +2. So we can think of it as taking away 2x or a -2x. Both ways are important. Because if I drew it, I would have to draw those x's as being negative. And that's what it would look like. So the first thing I'm going to do is subtract 5 from both sides. That gets rid of it. Now notice when I subtract 5 from both sides, that's a 0 pair. But what I'm left with is not +2x. It's still -2x. That did not change. And over here, this became -8. So I have -2x equals -8. And now divide both sides by -2. And I find out that the value of x is equal to a +4. If I wanted to check my answer, I can go back into the original equation and substitute 4 for my x. 5 minus 2 times 4 is 5 minus 8, and 5 minus 8 is -3. Question 9, we have subtraction of two mixed fractions. Now, there's two ways you can do it. You can simply subtract the whole numbers first and subtract the fraction parts second, but what we always learn to do is it's much easier just to convert both to improper. When we have 6/5, take away 9/8, which is the same question. Find your common denominator of 40. Change this to 48/40 and change this to 45/40. 48/40 take away 45/40 is simply 3/40, which is your answer. Question 10 is an integer question again. There is multiplication here and there is multiplication here. Don't forget, when thinking about order of operations, that is still a subtraction sign. So the product of -10 and -5 is +50. Take away the product of 5 and -2, which is -10. I need to use brackets there. So really this is +50 take away a -10, which when I keep flip change will become 60. Question 11 is algebra. Slightly easier. I'm going to subtract 8 from both sides to get rid of my constant. I have a -10th of x is equal to the sum of these two. 8 negatives and 3 positives will be 5 negatives. Multiply both sides by -10. And x will equal a +50. Question 12. What is the equation that shows the relationship between x and y? So the difference in your y column, which is 4, divided by the difference in your x column, which is 1. 4 divided by 1 is 4. So in the equation that represents the relationship between x and y, 4 will be my coefficient. Substitute the first ordered pair. So x is 2 and y is 20. See if they're equal. In this case, they are not equal because 8 does not equal 20. So in order for them to be equal, you need to add a constant of 12, which means the equation that shows the relationship between those two is 4x plus 12 equals y. Question 13 is your fraction question, a mixed fraction multiplied by a proper fraction. Change your mixed fractions to improper to start. Look to see if you can cross reduce when multiplying two fractions. You can't. So multiply your numerators, multiply your denominators, you get 33 twentieths, which as a mixed fraction is 1 and 13 twentieths. Question 14, you have 1, 2, 3, 4 operations. The first one I'm going to do is the division. So 10 divided by -5 is -2. The second thing I'm going to do is the multiplication. So -2 plus, what is the product of -3 and -4? It is positive 12. -2 plus 12 is positive 10. And finally, 10 take away 5 is simply 5. Question 15 is an algebra question. Your constant is -4. And how much of x do you have? You have a fifth of x. So really, this question could be written a whole bunch of different ways. It could be written as a fifth of x, which is this, equals -1. It could also be written as this. It could be written as this, and various other ways. So the first thing we have to know is that your constant in this equation is -4. So in order to get rid of it, I'm going to add 4 to both sides. I have a fifth of x is equal to the sum of 1 negative and 4 positives, which is 3. Multiply both sides by 5, and x will have a value of 15. If I wanted to check my answer, I could substitute 15 for my x and see if it worked out. -4 plus, well, 15 divided by 5 is 3. That would be -1. So my solution is correct. Question 16 asks you to find the equation for this line. In order to find the equation, you probably need to create a table of values of x and y. Your first x value is 1 and 6. Your second value is 3 and 8. And your fourth is 5 and 10. To find the difference in your y column is 2. Difference in the x column is 2. And 2 divided by 2 is 1, which means in the coefficient is really 1, but since 1x is not necessary, I could just put x. So then I substitute my first ordered pair. 1 does not equal 6, but if I add 5 to it, I create equality. So the equation that shows the relationship between x and y is x plus 5 equals y. Question 17, we have a division by a whole number. So the first thing I'm going to do is change my mixed fraction to improper. Then I'm going to divide it by 5, but think of the whole number as being over 1. My next step is to change to multiplication and use the reciprocal of the second fraction. The reciprocal of 5 is 1/5. I can't cross reduce, so I multiply my numerators and I multiply my denominators, and my final answer is 17/25. That is lowest terms. Question 18, I have order of operations. It says square bracket, so I have to do this first. Keep flip change. -4 plus 10 is 6. 6 plus 10 times -2 is the same thing as saying 6 plus -20. And 6 plus -20 is -14. Question 19 is your algebra question using distributive property. If I can get it to tap, there we go. So the first thing to realize is I could do it two ways. I could solve it using distributive property, which means I would have to expand. So 5 groups of 2x would be 10x's, and 5 groups of -2 would be -10. So that's the first thing. Or I could divide both sides by 5 and have one group instead of 5 groups, equaling -3. If I did it this way, I'm going to solve it using my grade 7 skills. Add 10 to both sides. Then divide both sides by the coefficient. X would equal -0.5 or -1/2, or whatever you wanted to say, or -5/10, I suppose, if you want to keep it in not lowest terms. Over here, you would add 2 to both sides. You get 2x equals -1. Divide both sides by 2. You still get the same answer as here, or as a decimal, -1/2. And finally, question 20, it says graph the relationship and determine the appropriate equation. So the difference here is 100 each time. The difference here is 200 each time. So 100 divided by 200 is really 1/2, or 0.5. So in the equation, I'm going to use the decimal this time just because I can. You need to say 1/2 of x, or if you wanted to, 1/2 of x. Either way is fine. I'm going to keep both of them. Substitute your first ordered pair, which is 100 and 100. 0.5 times 100 equals 100. Well, 1/2 of 100 is 50. And since 50 doesn't equal 100, I would have to add 50 here to get my constant. And my final answer is this, or if you wanted to, this.